let's talk about a huge shift in how we think, how we strategize. It's a journey, really, from a world where we thought we could plan for everything perfectly to a world where we have to learn to dance with risk. This is the story of the architect's gambit.
For the longest time, we thought we had it all figured out. We were architects of efficiency. We had these incredible tools like linear programming that let us map out a world of knowns. We knew the budget, we knew our capacity, and our whole job was just to find that one single perfect path forward. We were literally drawing up blueprints for success. It was a world of absolute control, all clean lines and outcomes you could bet on.
And then, well, reality hits, right? The things you thought were set in stone start to shift and move. Customer demand goes up and down. A critical machine breaks. The market does something completely unexpected. All of a sudden, those perfect blueprints look incredibly fragile. So the real challenge today isn't about finding the perfect plan. No, it's about building a strategy that can actually survive a world you don't fully control. So what do you do? Well, the answer is you have to invent a whole new kind of foresight. Instead of creating just one perfect blueprint, what if you could simulate thousands of possible futures? And that is the core idea behind Monte Carlo Simulation. Seriously, forget the complicated math for a second and just think of it as an oracle. It's a way to run your plan, your idea, over and over and over again, but each time with a slightly different random twist. It lets you see the full range of what could happen. You're not trying to predict one future, you're trying to understand the entire landscape of possibilities. And what's so cool about this is how simple little inputs can create really complex, surprising outcomes. I mean, just take a single die roll. The input there is totally random and flat. Every single outcome, a 1, a 2, a 3, 4, 5, or 6, is equally likely. We call this a uniform distribution. It's a simple, predictable kind of randomness. Okay, but what happens when you roll 2 dice and add them together? Suddenly, the outcome isn't flat anymore. The results start to bunch up, to cluster right in the middle. Why? Well, think about it. There's only one way to roll a 2, right? You need a 1 and a 1. But how many ways can you get a 7, a 1 and a 6, a 2 and a 5, a 3 and a 4? There are 6 different ways. So this new shape, this peak in the middle with the sides sloping down, that's a triangular distribution. And it shows us a fundamental truth. Even when your individual risks are totally uniform, the way they combine is not. A whole new reality just takes shape. And this, right here, is the most crucial point. If you only looked at the average outcome, which is a 7, you would be strategically blind. You'd be betting the whole farm on a single number, and you'd be completely ignoring the chance of rolling a catastrophic 2 or a game-winning 12. The average is a trap. It is, because it hides the real risks and the rare opportunities that are always lurking out there in the tails of the distribution. A real strategist doesn't plan for the average. They prepare for the entire range of what's possible. So to build these simulations, we actually need to create randomness. But it turns out, randomness kind of comes in 2 different flavors. Think of it like a library of randomness. On one side, you've got RAND. It gives you this smooth, continuous stream of numbers between 0 and 1. This is just perfect for probabilities, like, say, the 25.5% chance a machine might break down. It's a smooth flow of possibility. But on the other side, you've got RANDBETWEEN. This gives you solid whole numbers, like choosing door number 1, door number 2, or door number 3. These are discrete shocks, distinct choices. Knowing which flavor of randomness to use is absolutely key to building a model that actually looks like the real world. All right, let's put this all together in a final test. We have learned to see the world not as a single path, but as a whole distribution of possibilities. And now we face the ultimate challenge. This is where our new analytical intuition goes head-to-head with our oldest, most stubborn enemy, our own gut feeling. Welcome to the grand illusion, which you might know better as the Monty Hall Problem. The setup couldn't be simpler. There are 3 doors. Behind one door, a brand new car. Behind the other 2, goats. You get to pick a door. Let's say you pick door number 1. You have no idea what's behind it. Then the host, who knows exactly where the car is, opens one of the other doors. He opens, say, door number 3 and reveals a goat. And now comes the gambit. He looks at you and he asks, do you want to stick with your original choice, door number 1, or do you want to switch to door number 2? So what does your gut tell you to do? For almost everyone, the feeling is immediate and it is powerful. It's got to be 50-50, right? There are 2 doors left, so it's basically a coin flip. Switching, staying, it doesn't matter. But what if that powerful intuition, that gut feeling, is actually the illusion itself? What if it's a cognitive trap and it's blinding you to the much, much smarter choice? Here is the absolute key to the entire puzzle. The host's action, it's not random. He knows where the car is, and he will never open the winning door. So his reveal isn't just for show, it's new information. And that information fundamentally changes the game. He is basically taking the entire world of what if and carving it into, concentrating the odds in one specific place. This is the mathematical bridge we have to cross to see the truth.
Let's just break it down. When you first picked your door, what were your chances of being right? It's simple, right? 3 doors, 1 car. You had a 1 in 3 chance of picking the car. That means there was a 1/3 probability that your door, door number 1, was the winner from the very beginning.
Okay, so if you had a 1 in 3 chance of being right, that means there was a 2 in 3 chance that the car was behind one of the other 2 doors combined. Now, when the host opens one of those other doors and shows you a goat, he doesn't change your original odds. Your door still has its original 1/3 chance. What he's done is taken that entire 2/3 probability that was spread across the other 2 doors, and he's consolidated it all onto the one remaining unopened door. The odds don't reset to 50-50. They become 1/3 versus 2/3. So the takeaway here is massive. Switching isn't just a 50-50 guess. It is a strategically superior decision, and it's based on new data. If you ran this simulation thousands of times, the switch strategy wins twice as often as the stay strategy. And that's the ultimate lesson of this whole journey. In a world full of uncertainty, our ability to correctly take in new information and update our view of the world, our analytical intuition, is so much more powerful than just raw gut feeling. And that brings us to the final thought. See, the Monty Hall problem isn't just a fun brain teaser. It's a metaphor for pretty much every decision we have to make with incomplete information. It teaches us that our instincts, as powerful as they feel, can be deeply flawed, especially when new data comes into play. So the real question to take away from all this is, in your work, in your life, where else is your gut feeling trying to convince you it's a 50-50 coin flip, when in reality, a much smarter choice is hiding in plain sight?